Yeah, I'm recording now using Zoom. So do we need to share it in YouTube today, Kyle?
No, not really. We posted in the channel anyway.
Okay, there are some attendees as
Yeah.
well, so they can watch the class, and we'll upload this to YouTube later.
Yeah, anyone watching the class can ask questions on the Slack, and then we'll grab from there.
Right. Right, so share my screen. Let me hide this. Okay. So let's just start with Agile. And here in this introduction, we're going to talk about the old way of working in software projects and what's the new practices or frameworks that most of the companies today are trying to follow to gain agility while delivering software. So when I say agility, what it really means, right? Agility, you can see it as the time taken from your product owner or your business stakeholder coming to you or to your team with some business need that needs to be implemented as software, and the time that the team really delivers the solution in production so it's usable by this customer. Agility might refer as well to your and your team ability to react to changes in the environment, because one thing is certain: the business is always changing. So the business rule you implemented today, it's going to change next month. The two that you just bought today and you did that integration, that was awesome, it worked fine. Probably the company will change licenses in 2 years, or change tools, vendors. In 5 years, someone will need to refactor, create new adapters, create new integrations for the solutions, or the business might even simply dismiss the solution and to reduce costs because no one is using, it's not bringing value anymore, and tell your team to delete the solution, delete the stacks, delete the infra you provisioned. So how your team react to these business changes, right? First, I'd like to ask one thing. Who is already working with some kind of agile practice? It can be anything. XP, Scrum, a different way that your team came up, but it's agile. So who is working with it currently or have worked with it? All right, so around 50%. That's good. So for the ones that are not working with it yet, probably you will soon in the future because of you who's not working in these new agile frameworks, probably you're doing something like this. So there are some business analysts in your company or some architects, enterprise architects, solution architects, data security architects. They define a lot of stuff in their rooms, in their strange meetings there for 4 months. And when it comes to you, to your team, it's not at all defined. So you need to define again the details, ask more business questions. So you do the analysis, then you need to design the low-level solution, code it, then you'll have, if it's an enterprise, you'll have the QA team, quality assurance team. They will run a set of tests, They are really happy when they find bugs, and they just return the feature or the code back to the developers. So it comes back here to coding. It goes there for the QA again. And finally, after some months or more than 1 year, the customer comes back again and checks if the work is working as the software is working as expected. But from this moment where the customer was involved in the requirements, in the analysis, to the delivery of the software, it's a long time frame, right? It might be months or 1 year, and the business might have changed. So what you're delivering, who never delivered some project that when you delivered all the value that the business was looking for was reduced to a half, for example. I've done several of those. And because I work in a bank using this kind of methodology. So the business guys, the business stakeholders, in the end, they're not happy because they spent hundreds of thousands of dollars or millions of dollars in the solution, and it's not even working as they expected. And when they say, oh, you need to change this rule, it's not like that anymore as it was 1 year ago. Your team will say, okay, so I need 3 more months to analyze, design codes, test this again, and in 3 months you have this change back. So it's a slow process, and a lot of people get angry, business people mainly. So agility is basically delivering this value faster to the customer. And for being agile, you cannot hold, hold too much of this scope when the business stakeholder come to you. They can bring you a huge problem. They can say, figure out the ERP solution for this enterprise. They can say that. They are the business guys. They own the IT area, basically. But then the way it develops from there, the way you talk to these stakeholders, you design codes and deliver, that will change, right? So you get this big piece of work, and you're going to deliver it in small and useful increments to the business. So an ERP solution, right? Let's start breaking down the resources. Let's get just one resource or one function and develop it end to end and deliver it. The solution is not complete, but it's usable, and you can get it much faster than 1 year. You can get it working in 1 month, for example, or 2 months. So it's already bringing value, and it makes the business stakeholders keep engaged and funding the project mainly. So there are 4 main values in any Agile framework that you will find. And this basically derives from the Agile Manifesto, which you can find here. It's not a complex website, as you can see. It's like old HTML websites when everybody was trying to put up a blog. But if you click here, 12 Principles of Agile, you'll find the 12 here. And they're really simple when you read it. For example, deliver working software frequently from a couple of weeks to a couple of months. Well, maybe that's not too frequent anymore, but with a preference to the shorter time scale. When you implement DevOps practices and you implement these practices and tooling we are going to chat about in this course, this can be reduced for several increments a day. So this delivering working software frequently, it will be several times a day. But the principle is the same. We have the option now with these new technologies to give the preference for the shorter time scale that brings value. And it goes on. There are 12. Working software is the primary measure of progress. So it doesn't matter if you tested the whole system and it took you 4 weeks and all tests passed, all green, it's beautiful. The team didn't deliver anything, right? There's no value in it. It's just part of the process and more process. So coming back here, individuals and interactions over process and tools. This is about collaboration, effective collaboration, instead of just following the process of filling out spreadsheets and sending emails and waiting for answers 2-3 days after that. Working software over comprehensive documentation. Here there's a balance that we could discuss about how do you do software design and how you interact with solutions architects and application architects before coding the software and delivering. But working software is the main measure of success. Customer collaboration over contract negotiation. So just keep the customer close the most you can. And responding to change over following a plan. Instead of mapping all of the scenarios that could go wrong, and it really takes a lot of time to do that, and you won't map all the cases. Instead of doing that, let's go with the minimum that we know that brings value. If it changes next week, then we act on that next week. So this is agility, and usually this impacts the software lifecycle that you follow in your company. So when we talk about gathering requirements during design, development, testing, and deploying, we give preference for doing something like these loops, these little loops here that deliver in an iterative way and with a smaller scope. So the outcomes are cumulative, right? And this idea basically came from the lean thinking on optimizing processes. So if you read that book on, it's the famous book on DevOps. It can be the Phoenix project. It talks a lot about this, the lean thinking, and it makes an analogy to a production line with actual physical products. The idea is the same. And we're talking about some concepts that are borrowed from lean, for example, work in progress, in a minute. And that comes to the definition of DevOps. So if we have this new agile practice and we know that we can make our work better, delivering more frequently, why did we get this DevOps idea? What DevOps is really solving and how it's different from Agile, right? If you look at the company as a whole, and in fact, it's not the whole company in this image because everything starts from some business need, and you'll find areas like portfolio management And there's the finance guys, there's forecasting, quarter planning, the closure of the financial year. There are these big plannings in other areas. But when it comes to a low level, you have some business stakeholders here, some development team here, and you have the operation guys. Because a software, it's solving a business problem, but the development team is the project team. A project, by definition, in project management, it has a start and an end. A project doesn't go on forever. So this development team is delivering software that brings value, but software will fail, right? Different softwares will fail in different parts, but for example, your infra might fail at any time. Your network may face latencies that your application cannot afford. So these failures happen every day. The operations team, it's there exactly to look after the stability of the system and act on these unplanned problems and incidents that happen. So Agile is basically fixing this first wall here between the business and the development team, bringing the business together, to the inviting the business to the development process, where development guys can talk to the business, break down the scope, and validate that the software is solving the business value in a quicker way. And it doesn't focus, it simply doesn't focus on the operation teams. So now we are delivering faster software. We are delivering more frequently. So it means we are changing an environment that can be the production environment more frequently. And on the other side of the second wall, there is the operation guys that they are basically praying for you not to deliver as fast as you are delivering, because every time you deliver, there's a potential problem that may happen in this deployment, because every deployment brings more risks to the system. And when we get all the deployments in a system together and they are happening in the same time or the same day, you need to look at the complexity of all of these combinations, right? It's not just your software. It's your software that talks with Artifactory. It's your software that talks with, SonarQube, check marks, and it's another team's responsibility. So every time you deploy, it's bringing more risk to the production environment. So DevOps came to make the second wall, basically to tear the second wall. It depends on how the company implements that, but we don't have more the operation team and the development team. So basically what you develop with the business stakeholders is what you maintain, is what you operate and monitor. So a main change here, when you think about the list of tasks you need to do today, if you're working in a development team, you'll see features to be developed. You'll see a functionality to be developed. But now, tearing down the second wall, we're going to see in this board incidents and problems that happens in production as well. And everything will be prioritized together, because in the end, everything will bring a business value. So fixing a bug brings some value. Delivering a feature will bring value as well. And in terms of money, I can say. So there's someone that needs to orchestrate this flow, because it's getting more complex and complex thing. You're working in this team, so now not only you need to develop, design, and test your application, but also you need to handle production issues. So what should I do, right? What's the first thing I should tackle? That's when these agile frameworks and methodologies come in place. They offer you basically a set of practices that you might follow and you can adapt to your environment in your context the best way your team can and sees fit. Some of them, like XP, can be more prescriptive, telling you which engineering practice you should use. And some are more abstract, as Scrum, for example. Just giving you some guidelines and you figure out how to run it. You can make adjustments. So I'm going to just mention here two, Kanban and Scrum. Unfortunately, we won't have time to dig into it. So let's talk about Kanban. In my opinion, this is one of the simplest ways to get started with some kind of agile framework. If you are not doing agile today, please have a look at Kanban, because basically you need a board and everybody needs to agree to do Kanban. That's it. So in the Kanban board, you will have these benefits. You can visualize your work. Everybody can visualize work of everybody. You can limit the amount of work per column that you have. And the columns are up to you and your team to define. And you can enhance flow with that. We're going to see how work in progress can impact your team productivity. So this is an example of a Kanban board. So here we have the columns backlog, up next, next things to be developed or tackled, in progress, things being worked on hold, stories blocked, done, and questions. So this is a specific Kanban board for this team. Doesn't mean you need to follow this, right? But the team needs to agree on these columns. In this, from this board, you can get some metrics, right? You can measure the time, for example, from when a ticket was born here on the left in the backlog, and the time, the end time when this was done, and we call it lead time. So most of DevOps practice, they will focus in reducing the lead time that we have. And we can infer other metrics from this flow. You may have cumulative flow diagrams. That's basically a simple calculation on how many items are in to do, how many in progress, and how many are in the done column. And when you look at this board, one practice that really makes a difference is limiting the work in progress. What's the work in progress? In every column, that represents some kind of work being done. For example, we have here in progress and code review. So someone is doing a review. So these both columns here, they represent work in progress. The to-do column and the done column are not representing work in progress. So for these two in the middle, you're going to notice, and this comes from the Little's law, then when we limit the amount of tickets in these columns, in fact, we deliver faster. So if you're working in a team and you see here in the in progress column that every single person just got a new ticket to work on. So let's suppose you have 10 tickets in progress here. But at the same time, you have 6 other tickets in the code review column. So do you think the team will deliver faster working in these 2 different contexts at the same time? Or they should do something else? They should maybe limit one of the columns.
Context switching is not good.
Switching what?
Switching the context is not a good idea. So focusing on one thing, deliver that, moving to the next one is the best thing to do if we can.
Perfect. Thanks, John. That's exactly it. That's exactly it. And when you have different contexts, different projects, different services to develop or issues to debug, in fact, this time of switching contexts, it sums up being a great deal of your time during your day. So I had a nice activity down there for us to do. I don't think we'll get to do it, but let's see. Just to prove that the work in progress limitation helps you to deliver more. So one way to employ this is using your virtual board too, for example, Jira, and set the work in progress limit there. Jira supports it. I think in Trello you can do that as well. But if you have a physical board, you can just create some Post-it cards with a cross in it, just to fill in the space, you know. So when someone wants to move cards forward or backwards, they won't be able to because it's a red field with these Post-its with an X, for example. So you can do that in the physical boards as well. Any question up to this point? All right.
Hey, Dennis, just yeah. you don't have much time.
I know this. Thanks, man. So, okay. I won't talk about Scrum much, but I'd like to show this image to you. Scrum is the Agile framework that I see most companies adopting or trying to. And Scrum defines some practices that are very simple to understand when you read it. So you can read the Scrum guide. I think there's a link here. Well, the Scrum guide is public. You can just get it here. You can read it in 1 hour and probably you will understand most of it. But when it comes to practice Scrum, it's very hard because it defines some roles that we can see here. Which roles? Product owner, the team, development team, and the Scrum Master. And when you are working in a company in reality, it's hard to get these designed people to fill in these roles well. And it's part of the Scrum Master role to coach the team on agile practice and Scrum specifically. So in these roles defined in Scrum, and we have 3, the product owner is responsible for managing the product backlog. So everything about business that comes, the product owner will manage it, break it the most he can by himself in different features, stories, or epics that are big stories. The team is responsible for the actual development of the solution or tackling production issues, right? And deploying it. And the Scrum Master is responsible for carrying out the ceremonies we have in Scrum and coaching the team on Scrum practice. Now, Scrum has, as I remember, 3 artifacts. We have the product backlog. It's the backlog of the product. So it might have 1,000 items, right? Everything that comes up to the product owner when he meets with stakeholders, director of engineering, finance team, or any other business area, he can put it as a potential story in the product backlog. Then you have the sprint backlog, the second artifact. This is the backlog, but just for the sprint. And in sprints is the way that Scrum works. A sprint is a time range of 2 weeks, usually, up to a month, where the team agrees to a goal and to a set of stories in the backlog and work on that. And the third artifact is the working software, is the increment. So basically you just have these 3. So product backlog, sprint backlog, and the working software, nothing else. And production issues are included in this case as part of the product backlog and sprint backlog. And after the sprint, and before the sprint as well, Scrum also defines 5 ceremonies. So there's the planning ceremony for planning the next sprint, the sprint planning. Then you'll have, when the sprint starts, daily meetings called stand-up meetings. Probably some of you do that. After these daily meetings, you'll have the plan for the next 24 hours. So you plan for the day with your team. So these are quick meetings, 15 minutes. After the sprint is just finished, so potentially you delivered something to production, you'll do a sprint review. So you gather with your team and look at the sprint goal you defined in the sprint planning and present, well, to the team. It's just an activity within the team, right? You measure if you achieved what you agreed in the planning, basically. If you left one story out, the sprint failed. It's black or white here, basically. So if you delivered everything, okay, it was a good sprint. If not, it failed. And after that, you're going to do the 4th ceremony, which is the sprint retrospective, where you're going to discuss with the team how to improve the process. So this sprint failed, but let's not talk about the ticket itself. Let's leave the software outside. Let's talk what failed in the process and what's good in the process. What do we need to change to make this better for us? And it's a very unique thing. It's it depends on the context, on the people you have in the team, but it's a brainstorming session, and some actions needs to come out of this. And there's another ceremony, the last one. It's a demonstration session. And there you can invite not only your team, but stakeholders as well to show the increments you've done in the sprint. So it can even bug fix in production. So if there's something that's really bothering the team for a while and it was in the sprint, you fix that, show to the stakeholders that you fix that, and answer the team questions on how you fix that. Just present the contents and share knowledge, right? So that's it. This is Scrum in a nutshell. There's more content here on the roles, definition of ready, done, refinement. Please have a look at that. There are some games you don't have time to play, sorry. And yeah, and some other links here. Any questions on that? Did you understand anything? Too fast? Too slow?
I get it. Yeah,
Okay.
I mean, I've been working with Scrum since 2012, I guess. So, yeah.
Okay.
It's important to mention that from the next class, we'll start doing some stand-ups on our class. So you guys will have to tell what you have worked between the classes, provide some.
Is there a difference between when we say methodology and framework? I see you've given definitions for both.
Yeah, there is, yeah. A methodology describes a method, right? Which is usually a set of steps and processes that you need to follow. And a framework, it sets a baseline or some guidelines that might be adapted for you to follow. So it's about how descriptive the methodology is or the framework is. It can start as a framework, then it gets opinionated, describing engineering practices and process that you need to follow. So it's not really a framework anymore. You're defining a methodology because you need to follow these steps exactly. In my opinion, that's the main difference between them. Maybe someone can complement that.
Yeah, I think it is different from team to team as well, even in a single organization and single business unit, team to team, the way people follow this is different. Yeah, but the main focus is continuous feedback, quick feedback loops, and then move forward. That's what I found it as a common thing. Continuous feedback, and the feedback loops are quicker. That's what I found mostly common.
Yeah. All right. Any other question? Okay, so I'll hand over to Kiko or Kyle.
Yeah, it'll be me today.
Networking. Okay, I'll stop sharing.
Cool. Okay, I'll talk briefly about network for you guys because it's a big part of cloud as a whole. So because everything is outside your environment, you pretty much have the dependency of the network to reach everything that is on the cloud. And that's a big part of security in the cloud and provisioning in the cloud as well, right? these classes, normally we use a whiteboard to go through. So I'll try to use the part of the whiteboard that we have here, but I'm much better with a pen than with a mouse. So excuse me if the draws are not very good, but I have some diagrams in Draw.io as well to go through, which is probably going to be easier once we get into the AWS part, right? Initially for network, I mean, what is network exactly? Anyone can define what is a network is in some words? No one? Come on, you guys use network every day, guys. Come on.
A network is like a communication media used to communicate one app to other app or something.
Yeah, exactly. It's like any kind of network. You have a network of friends, a network in your work environment, and a network of computers is pretty much exactly the same. It's just a connection between two or more computers, mostly, right? So that's pretty much what network is in that area. And the computers use a specific language. We use English or any other language that we have in our country, but computers use specific languages as well to communicate between each other, right? And this is called protocol, right? Protocol is what defines the language that will be exchanged between each computer in that network. Cool. And the main protocol that we use today is TCP/IP. Probably many of you guys already heard or know about it. Honestly, I won't go into much further details on these protocols. I mean, we could have a specific academy just for network. That's not the purpose. We are just trying to cover here some basics network knowledge so we can work with AWS and the cloud environment with what we have there in network area, right? So in terms of the protocol, TCP is pretty much just imagine a communication language that will be spoken between those 2, 3, or any computers in that specific network. How each computer reads each other. Anyone have any idea on that? How computer, let me just share here, but whiteboard here. Share. So, and again, guys, I'm really sorry for that. It's the best we can do here. Format. So we have computer 1 here. You guys can see the screen, the
yes.
whiteboard?
Yep. Looks good.
So we have computer 1 here, and we have computer 2 here. Any idea on how those computers communicate with each other, how they find each other in the network? Because let's say that this is the network that we have, those 2 computers, how they find each other. We have a connection here, of course, but
You have an address.
IP address.
Post
yeah,
layers of voice model we have.
yeah, exactly. I mean, we have many addresses between those 2 computers. The most common that we know is MAC address, which is a physical network of the network interface on each of those cards here. We don't need to go that deep. We can just focus on the IP address, right? The IP address is pretty much a number that each computer receives once it gets to the network, right? Do you guys know how an IP is pretty much, let's say, not generated, but what does the IP means in terms of what the number that we got, like 172.162.10.1? Anyone have any idea how we have those numbers and the reasons behind those numbers?
You just have like 4 octets and they are translated to binary. So if you have all a full octet, a full octet full of ones, you're gonna have like 255. And if they are all zeros, you have just 0.
Yep. Exactly. So basically each IP is made by 4 octets, and those 4 octets is pretty much binary numbers, zeros and ones. and you have the numbers between for each octets from 0 to 255, which is 256 numbers, right? Cool. So if we have multiple machines here in the same network, so this is a tree, and okay, we have the connection here between, and if you have a fourth, everything connects between each other here. So this starts to become, we're probably gonna need to have these kinds of connections. And again, really sorry for that, guys. It's not the best thing to do, but if we have one or multiple computers connected in the network, things start to get pretty messy in terms of connection between each computer, because each computer needs to reach each other in the same network, right? So if you have, for example, in a network, let's say 200 computers, you would need the connection between every computer between each other, so each one can reach each other. In that case, we have something which is called a switch, which is pretty much which connects every computer between each other. So you don't need to have, for example, computer 4 connecting to computer 3, 1, and 2. You just have, let me just erase everything here. It's not that bad, okay? So we would only have, hold on. Draw. So we would only have something like this. Those are the 3 computers. We have a switch and everything is connected to a single point. So the switch is responsible by sending what is here to here to here. So just make the communication between all the computers in a network flow without requiring every computer to connect between each other, right? So this is one of the key pieces of a network, is a device that will make sure all other hosts in the network will connect between each other. Cool. And this is our network, right? So this is this specific network. Cool, but let's say that we have the IP addresses and we can have endless numbers of computers in the same network, right? So it would be pretty much impossible for a single device or even multiple devices to have everything connected between each other in that specific scenario, right? So that comes with a definition that we have in network, which is network segmentation, right? Let me just break this and I'll try to show, I'll stop sharing here and I'll just show, share my screen, and I'll go through some numbers here. So probably gonna be easier to go through that piece of network segmentation. Let's say that we have the IP address 192.168. This is one IP address of the network. This is another IP of the network. And let's say that those are the 2 computers that I have in my network, right? I could have in the same network for something like 192.168.20.20.10, or even completely different numbers like 10.10.10. Oops, sorry. And so, as you can see, we have 265 numbers here. Yep, 255, 255, 255. So if we multiply the numbers of IP that we have, would be pretty much impossible to have everything connected between each other without the network segmentation, right? Because every computer would need to know the path to the other computer, or everything will be in the same network without any kind of segregation. And that means that if I send a package to a specific computer, every other computer might also receive that package if we use some kind of process we have in network called broadcast, right? So we could send a message to everything, to every computer, and will be pretty mess without this kind of network segmentation. So anyone knows what is a network segmentations and how this is configured in a network environment that wants to try to go for? To avoid this kind of every computer reaching any other computer in the network.
We use subnetting.
Subnets, yeah.
Subnets, yeah.
Yep. That's pretty much it. So we have the concepts of subnet, which is a division or segregation of a specific network. And with the IP, every computer, when we get its IP address, it also receives something that we call net mask, which is something that will define which network that IP belongs, pretty much, right? So normally we have some specific kinds of network, which is defined by class. So we have class A, class B, and class C. Basically, as a nutshell, class A would be a network that has just the first octet, which would be this one, defining the network itself, and all the others octets would define the host IP address. We have class B, which defines the two first octets as the network, and the third and fourth octets as the host's range. And we have class C, which will pretty much use the three first octets as network address, and only the last octet as network host, right? And for that, again, we also gonna use binary. So let's say that this is the network. So it's .0/24, and this defines the match mask. This number represents all the binaries numbers that we have here as match mask. So we would have 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, dot 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So this represents that all those number ones in the network is specifying the network itself. So which network that IP address represents. So if I say that IP address is .10/24, that means that in this number, because it's 24, so this represents 24 ones here, pretty much, which converts to pretty much 2. So if you see your network configuration, you're probably gonna see this number instead of this, but it's the same thing. And this represents that all those numbers over here, so those three here, are the network that you belong. And those numbers here, those zeros in the subnet mask, represents combinations that you can use to define the host that will belong to that network, right? So these 10 here, if we convert that to binary, it will be 1, 2, 4, 8. So 1 and 1, right? So that will be the representation for this number 10 here in binary form in that network specifically, right? Any questions around here? Again, I don't want to go much further because this is not something critical. We can discuss, but it's just what I want you guys to understand is first how we define the network, what this number here represents, and how you define the network itself based on this number here. And I know that we have some network people here, so I think it's easy for them, but for anyone that is not very familiar with network or doesn't have played a bit, maybe just saw that in college or something. Any questions here?
Yeah, I have one question.
Yep.
It's like, as a DevOps engineer, how often do you need to do this sort of calculations, like in your daily work basis?
If you are responsible by defining the network structure in your cloud environment, and that's something that it would depend on the engagement that you have, the client or your position specifically, you might never do that, or you may do that, I don't know, every engagement. So You're gonna need that pretty much to define the network that you're gonna create inside the clouds, split the network that you're gonna have into multiple subnets and things like that.
Or you can use a tool like IPCalc or something.
Yep, and that's exactly what I'm gonna show here. There's plenty of tools in the internet. There is command line to do that. Normally I just go into Google and type IPCalc, and that makes our life much easier because, again, we don't use very often, and when you need to use, you don't need to go through all those binary and all those things. You can just use things like that.
Can I make a quick comment, Kiko?
Sure.
So we'll have a few exercises that involves doing the calculations. We don't mind if you guys just go on the website and put that. It's fine. We don't want you to know how to calculate. I probably won't know at first time if I just look at it. But you need to understand it, because when you get a 3 VPCs that have 12 subnets on it, and you are trying to troubleshoot some service that is not communicating to some other service that is on a different network, and you don't understand why, you will need to know at least a very basic of networking to be able to fix that.
Yeah, again, you don't need to know by heart all those numbers, those zeros and ones. The main thing that I want you guys to take from this is understanding how this /24 is generated, what does it represent. Yeah, and I'll go further after we are clear on that, on how different subnets communicate between each other, but that's the main thing that I just want to make sure everyone understand. And if you don't understand, it's fine. Just we can try to explain in a different way. It's fine, because again, it's not complex, but for anyone that never seen that, seeing all those numbers might be not easy. Yeah. No questions? Cool. Let me just jump into, so just continuing here. So as a subnet, that means that it's a subpart of a different network, right? So what a subnet means in terms of this is that we could have the network like /16. So this is a different subnet. It's a subnet, but let's call it as the network that we have our environment is 192.168.0.0/16, which means this is the network number, and those two other numbers here will be used by hosts, right? So this would be all zeros here instead of, right, instead of the ones. And this subnet here, which would be 10.0/24, would be a piece of the subnet here, right? Because this is the bigger subnet, and every subnet you can split between many other subnets, and each time you add one number here, let's say if it's /17 or 718 and 19, that means that you are splitting the network into two. So let's say, just to make it easier, because the numbers are easy in this example here. So here we have 256 hosts or IPs available. The first one is already used for the network itself, so remove one. The last one, which will be the 255, is used for broadcast. What I told previously is not something important, but assume that this IP 255 can be used in that scenario here, because it's used for sending communications for all IPs in the same network, right? So that leads us to 253 IPs that can be used by hosts, right? If we change that to /25, that would make these networks slightly smaller, because again, this would become a 1. So we only have those spaces here to identify the host, which would be, sorry, this would be a 1 here. 2, 3, 4. that means that instead of 256, now we have 128 IPs, right? So that means we just slice it, that slash 24 into a slash 25 means we just split the network in two. So we would have 192.168 and 128.25. Those would be the two networks, or the two subnetworks that would belong to the network that we have here previously, which is this slash 24, right? So those two networks belongs inside this network here. As you can see, everything can be a network or a subnetwork. It's just a matter of how we split things and how you're dealing with your IP ranges and network definitions. And again, we could split in 26, 27, and each time would segregate or split the network that we have previously in two, right? Fine with that concept of splitting networks and the concept that pretty much networks belong to other networks and so on and so forth. All good? Cool. I'll assume as a yes. Cool. Let me go back to the whiteboard, because now we have multiple networks, right? So previously the communication was happening between networks inside the same network, between computers inside the same network. Let's say that now we have one network here and another network here. We have those computers here. They are communicating between each other through a switch, which is fine. We have another network here. Everything works fine. And let's assume that those are different networks here, right? So we have 192. I'll just make 10.10.0/24. And again, sorry for this, guys. 192.10.20.0/24. So completely segregated networks. Those don't talk between each other, but let's say that we need those networks to speak between each other. So I have this computer that needs to talk with this one now, right? So we need that communication. Any idea, anyone knows what we need to do in terms of to make that communication happens?
We need a router.
Router.
Yep.
Yep. It's good to have networks guys here. They know that stuff. So yeah, exactly. So we need a router here, but we also need something that we call a routing table, right? The router, we know that in order to reach computers on this network, the traffic needs to be sent to this. And the router, we know that in order to reach computers in that network, that subnetwork, it will need to flow and send the package to that direction, right? But for these computers to know that how to reach these computers, we need a routing table here, and I won't write, but a routing table is pretty much a list of destinations that these computers here can reach. So let's say the destination will be 192.10.20.0/24. So in order to reach those computers in that network, send the traffic to this router here. So this router will have an IP on this subnet and one IP on this subnet, right? Because he needs to communicate with those subnet as well in order to send traffic between those networks. So what the configuration that we're gonna have on those computers is, if I want to reach this network, send the traffic to this IP of the router here. We normally use the first host in the network, or the last, not the last because the last is broadcast, but the one on above. But would be 192.10.10.1 would be the IP of the router. So every communication that needs to reach this other network here is sent to this router, and the router will know how to send the traffic to these other hosts in the network, right? So the component of the router is pretty important when you need to make different networks or different subnetworks to communicate between each other, right? So that's a key component that we need to take from this, especially when we start talking about how to design the network in AWS. Any questions in here? All good?
No, that's fine.
Sweet. Now let's.
Only one question on AWS. When you create a subnet, you need to check out the first address is the network address, the last address is the broadcast address, and you need to reserve how many more, one or two addresses you can choose.
You reserve, I mean, you don't need to reserve anything. AWS will reserve or will use 3 of the IP addresses from the network to manage a few things. The first one, the first IP would be the IP of the router as here. So
right.
The router would have the .1 here in this example. The second one is used by DNS resolution. So naming resolution inside your network. So it would be the .2. And the third one is reserved for something in the future. There's nothing in place yet, but they have a third IP address in the network reserved for something. All the other hosts will be used by resource that you create in your AWS network.
So the minimum number of address on a VNet will be like 4 or 5?
I think the minimum that you can have is /28. Which would be something around 8 IPs. So 8 minus 3 would be 5.
5. Oh, how good.
Right?
How good.
Yeah, I think that's it. Is that right, guys? /28, right?
It is /28. I think it's 16 hosts /28, but I'm not too sure as well.
Yeah.
I'll check for you.
Yeah, and I think 5 IP addresses are reserved to AWS. I don't remember. I think I found it.
Yeah, the first is the network address, the last is broadcast, then you have router,
that's correct. That's correct.
In one pre-reserved. But yeah, Kyle is right, is 16 IPs.
16.
Yeah.
Oh, good. Thanks, guys.
No worries. Cool, let me go back.
And also the biggest is /16.
Yep. Sorry, I just stopped it. Cool. Getting back to our beautiful diagram here. Let's say now that those networks are communicating between each other, it's fine. Now we need to reach something that we know as internet here, right? But again, and this is a concept of IP addresses. There is 3 ranges of IP address that are normally reserved for, let's say, internal or private networks inside the whole network of internet, which will be 10.0.0.0/8, 172.16.0.0/ I think it's 22, but I can get this. We have this in the repo. And the third one would be 192 /24, right? So those are the 3 main subnets that are not routable in the internet. So if you see, or if you look at your company where you work network, it's something in those 3 IP ranges. Your network inside your house is probably something like 192 as well, because those IPs does not go into the internet. It's just for internal purpose. So everyone can have their internal network for any purpose, and you're gonna have duplications of those IPs in each internal network. It's fine because those IPs doesn't go through the internet. But the rest of the network is pretty much for the internet. So anything different, those 3 ranges are on the internet. And sometimes, or most of the times, you need to reach different IPs like 19.7.7 8.2. That will be an IP that is on the internet. Google DNS 8.8.8.8 is IP that you need to reach not only from within your internal network, and you need to go here. So, but you don't have an IP address to communicate with the internet, right? Because those IPs 192, it doesn't go to the internet. So how your computer that you are currently connected now could be this one, is going to a router, which is your router, and coming here to the internet. Anyone knows how this is done?
Net.
Yeah, which is network address translation. So normally a router will have this feature on, which pretty much will get your package, which is your, let's say, a communication or a data that you're trying to send from your computer to the network, to the internet. The net will just pretty much envelope this information and will tag with its own IP address, because this IP doesn't go to the internet. So the router will have an IP in the internet. Let's say it's 1.2.3.4. So you just get your package, stamp with this IP address. So you will have this IP address going out the internet, and we'll have a table here saying, okay, I just sent this IP, this package here from this host here, and we reach, for example, this host in the internet. We'll get what it needs. I will come back here, and we'll just revert the process of enveloping the package so it can return the communication to the right host here, right? So the net process is very important, and it will happen everywhere that you need to communicate between different networks, and you need to use a specific IP address to do that. The router here, in some case, will also do the same process, even for communications between different networks. But let's consider that this happens for every communications that goes from an internal network IP address and network into a public network like the internet itself. Cool. Any questions on this? So good, all good? Awesome. So I'll just jump now to similar stuff, or how we do these kind of things inside AWS, right? But again, if you have any questions during these next things, just let me know.
I just remember something that I think would be nice to mention as an example of how, when we use subnetting on our day. So one of your exercise was to block the access on the private instance to only allow the public instance to SSH into it, right? And it was quite nice, as most of you use the secured groups as a source, or the network branch, network IP as a source. That was quite good. Normally, if you don't know anything about AWS, you just use 0000, which a few of you guys did that. We told you guys that what is the best practice. But then one case in specific, some of you, I don't know which one was it, put something like that, 10.0.0.0/24 as a source. So it was allowing the whole subnet, not just the IP of the instance itself. It works. It's better than opening to anywhere, but it's still not just to that instance. So if you want to point like to a specific IP on AWS, Kiko might show that later, you use, for example, /32, which is a single IP. When you put /24, you're allowing a whole range, a whole network range.
Yeah.
So in one of the first exercise, you already use some of those concepts.
Yeah, and will depend on the requirement of specific network configuration that you're doing, right? In some cases, using this /24, it's fine because all the IPs or all the hosts from that network will need to access that resource. That's completely fine. But in our use case, it's just yourself accessing that instance, right? So as tighten as you can do your security controls, it's better, right? So the security groups, if you can use /32, better, because again, it's just that specific address. But if you need to do for more, it's not a problem as long as it's part of the requirements for that. Cool. Sweet. So moving to AWS as a network, you guys can see this PowerPoint here?
Yep.
Cool. So we have the AWS cloud here, and we're gonna stick with a specific region here. Again, you can have multiple networks in multiple regions, but a specific network inside AWS is, it only belongs to a specific region, right? Networks is not across multiple regions. Networks are specific to regions. So if you have a network that you want to create into AWS, and that's specific to that region. Cool. And in each region we have the availability zones, which Kyle covered last class. But again, it's just thinking the availability zone as one data center, right? So that availability zone is fully segregated from the other in terms of failures, and everything that talks inside that availability zone is extremely fast in terms of latency and network speed. So it's pretty much a local area network, which is everything running in the same place, right? But yeah, so the region, we have more availability zones. I'm just covering here 2, because having 2 or 3 in that example is just more space to cover, but you can have more availability zones as long as the region has those AZs, right? So the first concept of network inside AWS Cloud is what we call a VPC, right? So VPC stands for Virtual Private Cloud, and that's where we start to define your network configuration, right? So the VPC is pretty much, it runs across all availability zones. So you have one VPC that goes into the entire region. You can have multiple VPCs inside your accounts. But that VPC will pretty much, all the communications inside this VPC will only be done inside the VPC unless you have specific connections between different VPCs. But for here, let's just consider a single VPC and the communication only for that VPC specifically, right? So for every VPC definition that you're gonna create inside AWS, you need to specify the network or the subnet that you're gonna, that VPC will have as IP address, right? Or not IP address, but as the CIDR, which is the network definition in terms of TCP/IP. So here we as an example, we have this 10.10.0.0/16, which means that anything after the 10.10 will be hosts unless we segregate that network into multiple pieces. But yeah, would be plenty of IPs into that VPC. And again, you can use any IP address here as long as it's part of the IPs that are not routable into the internet, right? So either the 10s, the 172.16, or the 192.168. Cool. Cool. So if we have this VPC and we have a few things that we can define inside this VPC, which is we can split this VPC into a single subnet, because this is not a subnet specifically, it's just the CIDR range, which this VPC will control. In order to have resource, you need to create subnets here. And that's when you start to split the network, this network 10.10.0.0 into multiple subnetworks, right? Because we're gonna need to create multiple subnets. We could have a single subnet that would match the same values for the VPC, that would work. But first we would stuck into a single AZ because each subnet belongs to a specific AZ. And honestly, you would lose a lot of possibility in terms of having resources in a more secure subnet, resources in a public or more public subnets without a lot of constraints. So we normally, when you have a VPC, we create at least 4 subnets when you're talking about 2 AZs, right? Normally one is private and one is public. And again, we have 2 privates and 2 publics because we are working with 2 AZs here, right? So anyone have ideas of which subnets we could have here for all those 4 here, for those 4 subnets? Anyone wanna take a guess or say?
Like you're talking about like a 2-tier application. We have one from front end and the other for the back end.
Yeah, that's the reason why we have public and private, because some of the resource needs to be public and some resource need to be private. That's the main reason. But how would we split this 10.10.0.0/16 into those subnets? Because we need to have subnets for this subnet here, for each private and each public subnet here.
For instance, we can use 10.10.10.1/24 in one and 10.10.2/24 in the second, and so on.
Yeah, we can split for any number after 16 and not the 17, because the 17 we only split the network into 2, but anything from 18, which splits this network into 4, up to 28, we could use it, right? So in that case, I'm just using /24 because it's easier. So that /24 means that the next octet we're gonna use as the networks itself. So it's 10.10. anything here. So from 1 to 24 would be possible networks here. I'm using 10.0, 100.0, 20.0, and 200.0, all /24 as my private and as my public subnets here, right? Cool. So we have all our subnets defined here. Everything belongs to the VPC, which is good. But again, as I mentioned previously, we have those 3 IP addresses that are reserved. So instead of having all the hosts here, we have one IP or one host as a router, the other as a DNS, and the other as reserved. And I'm not sure if everyone knows about DNS, but as an idea, it's just when you access internet and you go to google.com, the DNS is the one responsible by transforming that www.google.com into an IP address, right? So it's just a service that translate names into IP addresses. So no one needs to know Google's IP address. You just know google.com, and DNS does that magic for us, right? So every subnet will have its own DNS resolver, the router, and the reserved IP, right? So that would lead us to the number of hosts that we have in each subnet. With that in place, so everything here would be able to communicate between each other on each private and public subnets, and that's it, right? anyone knows what we need to do for those networks here, or specifically the public subnets here, to go to the internet? What kind of resource or component we need to include here in that network case?
Internet gateway.
Gateway.
Yep. So we have the component of internet gateway, which is this is tied not to a subnet, but to the VPC itself. So each VPC can only have a single internet gateway. And the network gateway is responsible by pretty much connecting that VPC into the internet, right? So it's like a component that will make possible the communication between anything that we have here inside the VPC into the internet gateway. Okay, so we have the internet gateway, and let's say that we believe that everything is in place here, and now we're gonna deliver or deploy some of the resources into some of our networks here. So let's say we deploy EC2 instances, which is, you guys play with that already, is pretty much a virtual machine inside AWS that needs to belong to a subnet. You can either define if you receive a public subnet or a private subnet, a public IP or not. So you can have a specific IP attached to the EC2 instance that will be communicating externally. Cool, so we have the EC2 instances here. Do you guys believe that this EC2 instance will be able to reach the internet now?
No. No.
No? Yes?
No.
No.
What is missing?
Need to add the routing, entry to the route table.
Yeah. So
here.
that's the thing that is missing here. So if we try to access this instance here, or if you try to access the internet from this instance here, it's not possible. I mean, that instance can even talk to instance on this subnet or this subnet or this subnet, right? The piece that is missing is the routing table. And with routing table, because we now configure that routing table to, let's say, send all traffic that does not belong to a no network to internet gateway. Now those subnets can talk to the internet because it has the requirements. Those are private subnets, so they don't need to communicate with the internet at this stage. So they will just have, they will also have routing tables here to communicate to this public subnet, to this public subnet, and to this. But it doesn't have any rule to go to the internet, right? So only instances in those two public subnets are currently allowed to go to the internet at this stage. Cool, so we have everything in place. Everything's communicating between each other, but yeah, we still can go to the internet here. There's something missing. Anyone have any idea?
Network access.
Sorry, Ben?
The NACLs need to be configured?
Yep, NACLs. NACLs stands for Network Access Control List. And NACLs are pretty much just a list of communications that are allowed to be done either in ingress mode, which would be from outside to the subnet. So in that way, so from this subnet into that subnet, this NACL will be covering ingress as things that come inside this subnet, and egress, which will be coming out from this subnet, this private subnet, into any other place, right? So NACLs would cover that part. So now we have all the NACLs configured to allow the communication between those subnets. We have those NACLs here allowing those instances to go to the internet, so which will mean pretty much an IP address. So everything is in place now. But again, those instances still can go to the internet. Anyone knows what is missing here?
So there's
Is the NAT gateway? NAT? Net gateway
Yeah,
or something?
the net gateway will be for those instances in private, but even the public ones, they,
Security group.
Ah, security. Yeah.
yeah,
Security group.
security groups.
Hmm.
The security group, and those covers similar things in terms of allowing things to go out and in, but there's a big difference between, there are a few differences between NACLs and security groups. The first one is NACLs are defined for the entire subnet. So the entire subnet will be attached to a single NACL. So everything that resides into that subnet will need to follow what is defined in the NACL. In security groups, it's attached to a specific network device, which in this case is the Ec2 instance. The Ec2 instance has what is called a network adapter, which is ANI, and the security group is attached to that specifically. Imagine that it's like a firewall, not inside, but that just controls that specific Ec2 instance. So this is one of the main difference between NACLs and security groups. The security groups is per instance, and the NACL is per subnet. Another difference is that in NACLs you can specify both allow and deny rules, and in the security group case you only have the allow rule, so everything is blocked and you need to allow everything in the security group. Just a second, guys. My cat is desperate to get into the room. Sorry. And the third main difference between NACLs and the security group feature is that the NACL is what we call stateless, because you need to define both rules for ingress and egress. So for example, if this instance will communicate with that instance here, you need to set in the NACL that it's allowed to go into that instance, and it also allowed to receive the response from that instance. And in the security group, you just pretty much, whatever you define in one way, which it would mean this instance can, for example, receive HTTP connection, which is port 80. Every response to a request in that, the response for any request will be allowed by default because the ingress already allowed. So in that case, the security group will keep the rule as both in and out in the communication process. Instead, in the NACL case, you need to specify both the in and out rules, right?
Can I make a quick one? So
Sure.
just another example for different NACLs and security groups. If you have two instances on the same subnet, you don't need to touch on NACLs. So essentially that's the difference. So same subnet, you're just dealing with security groups. If you need to communicate with an instance in another subnet, then you are going through the NACLs.
That's why we didn't have to change or configure any NACLs for the exercise, right? It just worked.
Yes, that's right.
Because everything was in the same subnet.
And it could be the case that each subnet will have a different NACL, and then you will have to do the setup on both NACLs as well. Or they can use the same NACL. Just need to pay attention.
Yes, but one thing I noticed.
Oh, sorry, go ahead. Man.
Oh, sorry, Kiko. The internal instance can't communicate, like the AWS CLI didn't work there, and the I can't access the S3 because I don't have route to internet. And I got like, what is wrong? And oh, I forgot this. We don't have connectivity here.
Sorry, let me rephrase the question from Fernando. It's actually not that, because in the example, the exercise, you are communicating between subnets. Why it works is because the default VPC that AWS offers to your account, it has an echo that allows everything. That's why. So you guys will now have a new exercise to create from scratch the whole networking. And then you see that if you use a custom NACL, if you create your own NACL, it will come as default by denying all. But the one that AWS offers to you, and when you create a subnet, AWS will automatically gives you an echo for that. It has allows all.
Great, thank you.
So potentially you can access your S3 service from the default one, just because of this that Kyle just mentioned. It has an internet gateway attached to it, and there's a route in the route table, but that's because this comes with the default VPC. Usually when you get into a company, they don't use the default one. Normally they delete it and they create their own with more restrictive accesses.
Good.
Yes, something that is important to mention. You guys created an instance in, let's say, in this public subnet without a public IP address, right? So without the internet IP. That doesn't mean that that instance can access the internet. It can, because you connect through the internet gateway. The only difference between having or not having an external IP in the public subnets here is that you won't be able to reach that instance from the outside into that instance, but the outflow, the communication flow, because it belongs to a public subnet, you have the routing capabilities to go to the internet through the internet gateway, right? So, and that's a big part, and that's really important to understand. That's the big difference between a public subnet here and a private subnet, right? The main difference between those two subnets is not that this instance can go to the internet, or that this instance won't receive an IP address. The main difference is that this subnet here is not connected to internet gateway, so there is no routing in that subnet to go to the internet through the internet gateway. But yeah, you can have a specific instance in the public subnet that won't have the IP address, and they will be able to reach the internet, as the example that you mentioned, the S3, the instance will be able to reach S3 because it's connected to a public subnet and going through internet gateway in that case.
Yeah, public and private subnets there is just names. You could call whatever you want to. This is just conventions. The main difference is what Kiko just said.
Okay, you don't need like a net gateway to feed the internet in this private subnet now. Only if the internet gateway is enough. The mistake was I didn't wrote like the proper host table for this instance. Now I got it.
And that's something that we need to just make sure, Fernando. The private subnets and public subnets, the difference, as you mentioned, is the connections to the gateway. But when you guys created the private instance, you guys didn't create in a private subnet. You guys created in a public subnet. So everything that you guys created was in a public subnet. The only difference is that one instance had a public IP, so you were able to reach that instance from your home. The other instance was right in the site here, but didn't have an IP address, so you could reach from the outside. But the instance, it could go to the internet, because the internet gateway here, it does a role of a net, because if you're routing, if you have an instance, let's say that this instance here on this, it doesn't have an IP address, right? A public IP address. So when that instance tries to go out to the internet, you go to the routing table. The routing table will say, okay, in order to reach the internet, you go to that internet gateway, and that instance will go to the internet gateway and will be able to flow to the internet. In that case, the internet gateway will be doing something, what is a net here. So the internet gateway has an IP, and all the communication that go to the internet will go with the IP address of the gateway. And once the communication goes back, the internet gateway will look at its table, say, okay, this request was from that instance, and it will come back here. So that's the big difference. We never use private subnets up to this point. We only use it public, but instance with public IPs and instance without public IPs address. Is that clear?
Yes, Kiko, thanks. Now I got it. Was the lack of the IP address on the public subnet. I got it. Thank you.
Nothing about private and public subnets.
I'll go. I got it.
Awesome.
Oh, I just realized now again that it's wrong what I just said before. One more time.
Come on, Kai, you're getting me confused now.
Yeah, sorry about that. And it's right. The default VPCs and subnets that AWS provide, it's all public. It's all linked to the internet gateway. You don't have a NAT gateway on your account because a NAT gateway, it's out of the free tier.
Yeah.
And then you have to pay for that. So sorry about that. It's all public, and then yes, you didn't go through the NACLs, but it's still right what I said, that the default NACL that AWS provides, it's all open. It doesn't have any blockers.
Just in case, I will wait a few moments to take note of that. Just in case.
Just in case. Yeah.
So we have everything communicating now. Those instances here are able to communicate with public subnets. The public subnets can reach the internet. But we also have the case where, let's say that we have instances here that we need to reach the internet because you need to get patches. It needs to, I don't know, access an API or something like that. You guys already spoke about that, but we have the figure of a NAT gateway. And NAT gateway is a specific resource inside AWS that you connect to a specific subnet. And in that case, we have one in the public and one in the other public. So we have a duplication here. In some cases, you don't need to have two. Just keep in mind that if you only have one, all the routing from those instances needs to go through this NAT gateway, and that's a single point of failure. So it's not ideal for production environment for test purpose because NAT gateways has a cost. We normally, in what we create here, we just have a single NAT gateway, and the NAT gateway is responsible by making those instances now in a private subnet to go to the internet, right? And any idea how we do that, where we need to do configurations for this to work?
The NACLs?
In where, sorry?
The NACLs?
The
NACLs will need some kind of configuration, yes.
The route table in here.
The route table.
Yeah, the route table here will need to be configured for that. So in order for an instance in the private subnet to reach the internet, the routing table that is attached to that subnet needs to say that, okay, so for any request going to the internet, which would be 0.0.0.0/0, and that's not the internet. Let me clarify that. So in a routing table, and for some of you that may be clear, and you guys probably already know that, but I reckon some might not know. But in a routing table, as we stated, we have destinations and the path to that destination. So if we come back to that network, or even here in that routing table, we would have something like, okay, so if I want to reach that network 10.0.20.0, please send the traffic to that router that will communicate to that subnet, right?
Sorry.
Sorry? Oh, no worries. So yeah, for this subnet to communicate with this, we're gonna have one entry in that routing table saying, okay, for the subnet, send the traffic here. Same for the private. If I want to reach that subnet, please send the traffic to that routing table, to that router. And for the internet, and in the case of, if you want to have something that is what we call a default gateway, which means if there is no routing definition for this specific destination, which is 0.0.0/0, which means for anything that is not in the routing table, like an else in a programming language, if else. So for anything that is not defined here as a network, send the traffic to a specific place. So in that case, we would have in those two routing tables, for 0.0.0/0 destination, send the traffic to this IP address here, which is the IP address of the net gateway. You won't say the IP address. In AWS, you're just gonna specify the resource name of that net gateway, and these will make these instance in the private subnets to be able to go into that net gateway. That net gateway will do a net to this IP address, and the net to gateway already knows the path to the internet through this routing table from the net gateway. So we just go to the internet gateway, and the internet gateway will do a different net here. So it's a net over net here, and the communication flows to the internet. And when the communication returns, you go to the same path. So the internet gateway will send to the net gateway. The net gateway will send to this instance here, right? So that's pretty much the main things that we have to cover around AWS and networking. There's a few other things that we have in the repo, and let me just get the and before I go to the repo, any questions with anything in that area here? I know it's a lot of information. Most of you guys, I think, already know a few things about that, but if anyone doesn't got anything, yeah, let me know and we can try to cover in a different way here.
I have one question.
Sure.
So for example, in this structure to connect to one EC2 instance, I need to modify the security group rules to be able to like allow my IP or my network to connect to it?
Yeah, so you're gonna need to configure two places. Let's say that you have an instance in the public subnet here. You would need to have the configuration both in the security group and the network ACLs, because the first, let's say the first test or the first thing that your communication will try to, in order to get into that instance, you'll go to the NACL because it's in the subnet level. So before getting to the subnet, the NACL will validate that you can go through. So you need to have that rule in the NACL allowing the communications to go into the instance. And in the instance, you would need to have the security group also configured to allow that, right? Also in the NACL, depending on the communication, normally when we talk about TCP, it's a two-way communication. So the communication will go in that direction. So from your computer to the EC2 instance, and then the EC2 instance will send some packets back in the communication flow. So the NACL will also need to allow the instance to go back in that way and communicate to your computer. So you need both in and out rules in NACLs and the in rule in security group for that to work.
Okay. And the last question is, I remember configuring the security group, like I had the option to set the CIDR, like just putting like a range of IP or my IP,
yep,
which allows, and the other option would be sort of referencing some other security group to allow this connection. How this works, like how two security groups communicate between each other?
That's internally in AWS, but when, let's say that we're gonna communicate from this instance into that instance here, right? So from the public here to the private here, when the package goes out from here to here, again, it goes to the NACL and it goes to the security group, and the security group will just validate what kind of rules it has. But during this package being sent, AWS has some ways to check that package is coming from a specific security group, which is this one here. And if you have an allow rule coming with a package coming from that specific security group in that specific port area you're trying to communicate, AWS will allow that communications to flow as well. You can't use security groups in the NACLs, if I'm not mistaken, but I don't think you can. It's only in the security group level. Network ACLs is more about IP address and protocols itself. But yeah, in security group, you can allow a specific security group to do that. And you guys will see that in the future when we talk about load balancer and things like that. But that's mostly used for those cases where you have a security group for a load balancer, and the load balancer will send the traffic to EC2 instance or containers or whatever. And it's much easier to use the security group there instead of IP address, because the IP address can change or things like that. So it's a best practice to use security groups when you can, because that would normally won't change.
On the load balancer case, it could be one use case for load balancers is when you have multiple subnets. It's, for example, you're having instance running on different subnets. So you need 3 rules allowing different CDRs for each subnet. So you can just use the same subnet for those instances.
Yep. Is that clear, Guilherme?
Yes, thank you.
No worries. Any other questions, guys and girls? You guys gonna have some exercise to do everything that you have in this picture here. So it's gonna be a good exercise to understand, and you're probably gonna have some troubles along the way because something will be missing, either an echo or routing table. Just try to remember all those things that I said. So you need routing in place, you need the echoes, you need security groups, the net gateway. Everything is a piece in this communication, and yeah, that's pretty much it about it. There are a few things as well that I don't think we have much time, but yeah, I mean, you can have connections between those VPCs to on-premise networks in the company. So you have your own data center. You can make the communications happen between the VPC itself and your internal networks and your internal. So you can have things like VPN connections. You can have direct connect, which is a dedicated connection between your data center and AWS. But those are things that we won't use here. It's more if you're interested, we have more things inside the repository providing this kind of information, as well as I mean, VPCs are isolated, right? So you might need one VPC to communicate with a different VPC. And you have what is called VPC peering. So you just connect 2 VPC between each other. You also have to make some changes in the routing and ACLs for that to work. But it's also something that we won't have a lot here in the course. But yeah, there's also a few additional information around that in the repository if you want to get more knowledge around it. But and also we are more than happy to discuss things with you guys if you want to learn more about specific things or about direct connect or VPN or VPC peering. Just reach us out and we can discuss. But I think that for what we need for the course and for the rest of the class in the future, I think what we cover is more than enough. But yeah, if you guys have any questions, we are more than happy to.
Quick one on the exercise. So as Kiko just mentioned, we are not going to cover much on VPC peering. It's getting deprecated, kind of deprecated as we go. There is other ways of doing these days. But the last exercise, it's a kind of a challenge. It's optional if you want to do it or not. It's a VPC peering. Ideally, you will get someone else to work with. Like you could potentially have 2 VPCs on your account and do yourself the peering, but that's an opportunity for you guys to work with your friends to do some VPC peering across AWS accounts. Then just one tip when you start going through all the exercises, try to pick some different CDR ranks. Don't everyone just use 10.0.0.0/16, which is the most common one. Because when you're doing the VPC peering, remember it's 2 different networks that you need to communicate and that they can't have the same CDR. So one of you guys will need to redo the whole work. So just a tip. It's the last exercise and it's optional if you want to do it or not.
right, should we do a break of 5 minutes, 10 minutes?
You guys happy to continue? We still have a bit to cover.
Yeah?
Yeah, go on.
Yes.
I say we take 5 minutes just for people to get some water.
Yeah, it's a good idea.
Stretch the legs. Oh, 5 minutes, we are back.
Okay.
Okay. Okay, so we're going to talk about the AWS CLI and AWS IAM service, Identity and Access Management Service. Well, the AWS CLI, you had some contact with it in the first exercise. And we're going just to see some commands on how to configure it and some other details, but high level, because AWS CLI basically can do almost anything you can do via AWS console. Because the way AWS works is it basically exposes APIs, REST APIs over HTTP. And the CLI is just one tool to interact with these APIs. You could even interact with AWS APIs directly if you want to, but you need to do the authentication process first. And AWS Identity and Access Management Service is a service responsible for authentication and authorization of users in the AWS ecosystem. So it's used by several services inside AWS. And it's the same service used when you, for example, you log in into your AWS console and you try to perform an action. So if you spin up an EC2 instance, as you've done via CLI for the first class, basically before spinning up that instance, AWS is checking with the Identity and Access Management Service if you have the permissions to do that. So let's get into it. Let's get started with the CLI. So at this point, you have installed the CLI already. So I'll skip this. Basically, it's an easy installation, and they just released a packaged version of the CLI, and you don't need Python installed anymore. It's all there with all the Python packages that you need for running it locally. Now, configuration. So if you have CLI installed, probably you can type in your terminal AWS and you get something like that, or even better, you can check the version and you check your AWS CLI version. But now for performing an action, you need to configure a user to perform that action, basically checking the permissions before performing it. And for that, using AWS CLI, you can use the command AWS configure. And what you find here when you do it is that AWS will ask you some information regarding the keys and access keys. It's like your username and password in AWS for an user. And that's basically it. After configuring this user and secrets, you are able to perform actions on behalf of this user. We'll get into the details of what an end user means and how you can create a new user soon in the IAM service. But now that's enough to know that you can configure users in your AWS CLI. And by default, AWS will store this configuration information in your home folder /.aws folder. So I'm using the default path here. So if I just list what I have there in my home folder .aws, you'll find two main files, the credentials file and the config file. The credentials file will have the access key ID and the secret that you just configured using AWS configure. Something like this. Here I just masked the secrets and the IDs, but you find something like this. So here I have three different profiles. We'll see profiles in a minute. And each one has a different access key and a different secret key. And profiles are just an easy way of organizing locally your users. So basically it's an alias that you give for these credentials. So what do I have here on my local in terms of profiles? You can check that by running AWS configure list profiles. You can see I have three here. Git user, continue.dev, continue STS. You can also run AWS configure list and see which profile you're using at the moment. So right now I'm using this continue.dev profile. It has this access key and the secret key, which is masked. And you can find this configuration information in the config file and the actual credentials in the credentials file.
Just one query. Is
Yep.
profile the same as user?
Sorry, can you repeat that?
Is profile the same as user? Like the users that we have, they are the same thing?
No.
No.
The profile is just an alias. You can give it any name. So I'll configure in a minute a profile with a different name than a user. And the user is the actual identity that you have there in the IAM service. So for example, I'll have an user Dennis, but I can configure that in my CLI as Dennis dev profile, for example.
Okay.
So they are separate. And profile is just it. It's just like an alias. And you can just use different profiles, because when we are working in the enterprise, usually you have, well, several users or several roles, and you have several AWS accounts as well. So during your daily activities, you need to switch between users to perform actions in different accounts, right? So the profile makes it a little bit easier because you can just use this environment variable, for example, AWS profile, and pass the name of the profile you want to use for that session. So in this session here, I'm using this continual dev. Let me just check if this is set here, probably. Yes. So my AWS profile envvar environment variable is continual dev. If I want to perform another command in another AWS account, for example, using another user that I have there, I could just switch here to this different profile. And then I could perform the action that I need to do and just come back to my previous account and keep working. So that's one of the benefits of
You
the
can
profile.
also have the default profile, right, Dennis? Which means if you don't have this variable defined, you just use the default one.
That's right. So you can have the default profile, which is called by default, right? And you can find it in the config file usually. I don't have a default profile. I deleted all of them. But yes, you can have a default profile. So that's the one used when you don't set the AWS profile environment variable. There are other ways of setting, of configuring the CLI, right? You just saw configuring using access key and secret access key. You can use these profiles to make it easier. But depending on the authentication you're doing, you might want to use as a session token as well. When you use a session token, when someone, or maybe even you, created a temporary credential that has some expiration date, and you're allowed to use that access key and secret key just for that period of time. In this case, you need to configure this AWS session token too. And as you can see here, I'm configuring it in a different way. I'm not using AWS configure command here. I'm just exporting 3 AWS environment variables. And the AWS CLI will look up these environment variables before performing the commands. So this is the second way of configuring that. And of course you can unset it, but then think a little bit about this. So one question for you guys. If I did a AWS configure and I set my access key and my secret key, right? Let's suppose I used the default profile. So it's working well. Then I come here and I export these 3 environment variables. And let's assume here that it's a valid access key and secret access key. So what's the precedence? Which one the CLI will use?
Use the last export.
The last one.
The last one is this one?
Yes.
Because was the last one to be set it? Or what's the reason by because it's this one?
Yeah.
In the first bash session.
The rule that the CLI uses.
Probably because has been set for the this export, but if you change back like to export the profile, it sets those variables for the profile. What?
No.
Does it override?
In this case, it will always give precedence to the environment variables. You can find here in the documentation of the AWS CLI that basically credentials from environment variables will have precedence over credentials in those files that I showed you, the credentials file and the config file. But if you set AWS profile environment variable and access key and secret access key are also set, then the access key and secret key will have precedence always. So as you said, Guilherme, it doesn't matter if you set it before or after. If there is an access key and secret key there, it will try to use it. So just keep this in mind in case you find, like during the exercise, you find a strange error and you're playing with permissions in AWS. Just make sure you're using the right credentials, because there's this convention in the AWS CLI.
Yeah, and that is a reason why they have two ways for like adding those credentials.
I think this is because if you reflect about this flow here in the AWS configure, how many users you can configure here?
That is no limit. Yeah.
Yeah,
I guess.
And using these environment variables, how many you can?
Only one.
Only one, exactly. So this is for temporary access. So
And that is, and are you able to set the token in the profile as well? Like in the AWS configure?
Sometimes. If you're using, like I'm using here, I'm using the Contino Dev AWS account, and Contino does federation for authentication, right? So I'm signing in to Google, getting something back, then going to AWS and exchanging this thing for a set of permissions. When we do this flow, like federation, this key that I get back, it has an expiration date. So even though I'm using profiles, I do have a session token, and this will expire. So the simple answer is yes, you may have session tokens with profiles.
Okay.
And for knowing who you are, there's a very important command, because when just using AWS CLI, if I just open the terminal, I don't know exactly which profile or environment variable it's using. I don't know which user I'm using. So you might want to use this service called STS from AWS with these commands, get caller identity. It's basically asking AWS, execute these commands, bringing me back which identity called it. So who am I? And here you can see that I'm this thing. I'm assuming the role. I'm a role. We'll get into it in a minute. But I can see which role, which set of permissions I am executing commands in the CLI. If I change my profile as we did just before and call again this command, it will return something else because I just changed the user. that I'm performing actions. So it's useful. You do need access to STS to do these commands, because by default, and we're going to see that, every user is created with no permissions in AWS. No permissions is no permissions at all. So even for STS service, you need permissions to perform it. So just keep that in mind. So in the last case, just go to the console with another user and try and check the permissions for the credentials you're using. So this command will return something like that. When using an user instead of a role, as I'm using, it will return the user name. Okay, one last thing on the CLI. This is a very quick introduction. And this is the most helpful command we'll get in the CLI. So you can type any command or sub-command in AWS CLI plus help, and it will navigate to the documentation of the command. So AWS help will bring everything about AWS. So it means here, for example, that for any AWS command that you run, you can pass --debug for getting debug information. So if I run this, it will give me details, as you can see. And as I mentioned before, it's just doing API calls. So you can really see the API calls here, the post API calls it's doing. Now let's get a little bit more deep into the commands. Let's suppose I don't know what I can do with S3. You can type S3 help and will give you just the S3 manual. Then I can see here it has some commands. So let's see what S3 ls command does. So you can type this again, ls help, and it will give you documentation just about the ls S3 command. So it's very useful. It's very useful. So just try and guess it, because every service that we talk about, just Kiko talked about VPCs, right? We talk about what? Internet gateway, what else? Subnets, NAT gateway. Let's guess internet gateway. Do you think I can find internet gateway here? Let's check VPC, for example. What VPC has? Several stuff. Yeah, VPC, maybe not VPC. I got the wrong subcommand. VPC. Oh, there's no VPC. Ah, because it's in the EC2 service. Okay. You can always, that's a good tip. If you don't know where something is, you can just type in Google AWS CLI, like VPC. It will lead you to, for example, this command, create VPC. That's good. Where is it? Ah, it's under EC2. So you can figure out a command like with 2 clicks. It's really useful. So under VPC, under EC2, can I play with internet gateways? Yeah, I can. I can delete an internet gateway, for example. Probably I can create one. So that's just an example, guys, but you can discover a lot of things just by playing with the CLI. If you don't find it, the same documentation you have there in the terminal, you find it here as a web page. And you can just search it. Might take a while. Okay. So that's it for CLI. Any questions on CLI?
Are you using any autocomplete or the AWS command?
I don't know. I might. Let's see. No. But you can configure that.
Okay.
Yes. I think I'm using something for Git. Yeah, for Git, I do have it. But you can install it. Probably the package you installed for the first class. If you did install on my SH, there are a bunch of plugins you can install for example, auto completion for AWS CLI.
Okay, that's fine. Thank you.
There's another neat tool that we use called AWS Shell, AWS-Shell. It's like a wrapper to the CLI. That's pretty cool. I found it sometimes very useful.
Okay.
Give you a drop down with every command.
Okay, so it's what's the difference? It's just about auto completion, or
yeah, sometimes it's much easier to, get the options like that and a bit of a docker underneath.
Looks nice. Thank you very much for the tip. I'll install it right away.
Feel free to send a pull request to add that as a reference for the content.
Yeah, please, and send in the Slack channel too. That's nice. All right. So I'll move on to IAM service. So identity and access management. It controls authentications and authorizations. Who can differentiate for me what's authentication and what's authorization?
I can do that if you like.
All right.
So authentication is proving who you are, and authorization is what you're allowed to do.
Perfect, perfect. That's exactly it. So when you log into, well, some service or website, basically it needs to authenticate you first. And what follows that usually is authorization. So can you authorize something that you don't know who is, what it is? No, right? So authorization will follow authentication usually, because you need to fetch some kind of identity before checking which permissions that identity has. And when I say identity, why I'm not using users as the word, right? Because an identity can be several things, including users, but as we are going to see, it can be roles in AWS. But for different systems, there are off-the-shelf solutions in the market. They might use different identities if they want to. So what are the two main identities we have in AWS? I mean, three. We have three, right? From these four, what do you think? This one is easy.
First three are the identities.
Users, groups, roles.
User, groups, and roles. Users, straightforward, right? What do you think is a group?
Collection of users, like who are allowed to do a specific task. It could be HR, admin, specific set of users.
Yes, that's correct. And what comes to be a role in AWS?
You can assume a role for some time and do something. It's not a permanent thing, so you just assume it.
But what it is?
Access to particular services, like within AWS, what kind of access would be allowed?
Yeah, that's true. It allows services to assume an identity before checking permissions. That's true. But only services can use roles, or
Permissions.
No, it could be any.
Okay. Let me explain. I'm trying to get the class from you. So that's right. What you said is right. It's just not complete. There's one more thing to be added. So just going step by step, users are the users like the ones you have for accessing the AWS console. User, it is an identity, of course, in AWS. And it might access services via two main channels. It can access via console, or it can access services in a programmatic way. Programmatic means CLI, a programming language. It's a non-interactive way, right? So users can access services in these two ways: interactive using the console, or non-interactive using CLI, for example. And I'd like to highlight this here in this class, but it will be useful for all services you have in AWS. This is an ARN, if I'm not mistaken, Amazon resource name. I'm guessing, but we can get it here. Yeah, Amazon resource name. An ARN is created for every resource that you create in AWS within a service, for example. So when you create a EC2
It's
instance,
a kind of unique ID, right?
Yes, exactly. It's an unique ID. It contains a lot of information. It's not like a number only. As you can see, it's composed, separated by columns. And as you can see, it has the service name in it. It might have the account ID in it. It has other identity and other entities under it, / something. So it will vary by service, and you don't need to know all of the ARN formats in AWS. The takeaway is, if you created a resource, probably it has an ARN, and you use these ARNs for a lot of operations. So if you want to, I don't know, delete a S3 bucket, for example, if you want to terminate an EC2 instance and several other cases, the CLI will ask you for the ARN of that resource. So in a similar way, when you create a user, you'll have the user ARN.
And one more important thing, as I would say, is for IAM policies, when you define the resource that you're gonna have certain permissions, the ARN will be used for specify which resource those permissions are valid for, right?
Yes, perfect. I'll show an example in a minute, but they are essential when you're defining the permissions. We'll see that in a minute. So groups A group is a collection of users, as you said, that's correct. And again, you can specify permissions for a group. You can also specify permissions for users. I didn't mention that, I think. These are identities, right? Including roles. And the only building block left here is the IAM policy. And this is all about permissions. So just going back to the role, it's an identity with permissions. The key difference is that a role is to be assumed by something. And this something can be a user, it can be an AWS account, it can be a service. It depends how you define the permissions of whom can assume this role, but it's intended to be assumed. So you cannot, this sentence sounds strange for some of you that know AWS more, but you cannot just log in using an user in the console directly. You need to authenticate first, right? We just talked that there's no authorization if there's no authentication. So the way I log in AWS using this account from Contino is that I authenticate in Google first. Then I get something back and then I authorize. Well, if you go to AWS console directly, you won't find an option to log in there using the role. So it's intended to be assumed. That's the main difference. And finally, it gets us to the final building block of the IAM service, which is policy. And under policies, we'll have permissions. So here, basically, you can define what can be done, by whom, and to which resource. And that's exactly the format you find in a policy. So have a look at this policy structure. What we have here is basically a set of statements. Every statement will have an statement ID, and you have some configurations here: effect, principal, action, resource, and condition block. So version and statement ID, these are just configurations of the policy. They're not a really important part of it. Now it comes to effect. Effect can be either one, allow or deny. So this action will be allowed or denied given that it came from, then you have the principal. The principal, you won't find it in every permission, but it's just because there are several types of policies. Some of them are called resource-based policies. So for example, for these resource-based policies, when you get a thing like an S3 bucket, and in this S3 bucket, you define the access policy in there. So you are not defining this policy for an user. You're not defining it for a group, neither for a role. You're defining the policy in the resource itself. So this is called resource-based policy. And in this case, you need to identify the identity because the resource is the resource, right? It doesn't have an identity. The other three we just saw, they do have identity. So this is the principal field here. We just need to pass something like this or any other identity to it, right? Then what follows is the action. The action is literally what you're doing. So as we saw the commands for deleting internet gateways, we saw there's a command like this, right? So what's the action here? The action is using the EC2 service, I'm calling the function delete internet gateway. And here probably I need to pass some parameters. So this is the action, what you're doing. And finally, yeah, of the important ones, finally we have the resource. And the resource is which assets this policy can be applied to. So for example, if I have here 5 internet gateways, it's possible to define a policy where I can delete internet gateway for just one of them. For the other ones, it will be denied by default, right? So the source, the resource is what you're acting in, but it can use wild cards as well as a star, you know? So you can define a path and use star, meaning that all resources in that path or with that partial names are included as resources of this policy. And finally, the condition, you can specify certain conditions for this policy to be applied or not. So let's have a look at an example. Have a read here, and who can raise the hand to say what this first statement of this policy is doing? Anyone? So remember, effect, allow or deny, action, what you're doing, and resource, the resource where the action is affecting.
Allowing all resources to change the IAM password.
Sorry, Fernando?
Allowing all resources to change the IAM passwords.
Not exactly. Almost that.
Users can change password from themselves.
Users. Why do you think it's the user?
These stars like users
I
are
didn't say one thing on purpose.
I think this means allow all the IAM users, IAM groups and roles to change the password.
Yeah, exactly. I didn't say this piece of information, which is very important. So the question would be to which kind of identity you attached this policy to in order for you to have a full answer. Of course, you can answer in a relative way as Guilherme did, and that's correct. So this policy is allowing the entity to which it's attached to change the password. And here it doesn't matter the resource. So it's allowing a change password of any resource. I think that the third one is filtering. It will become easier. But when it uses wildcards here, like this star, it's not really filtering by any specific resource. The second one, what is it doing?
It's allowing any resource to list the buckets that I created.
It's allowing to list all buckets.
The buckets I created.
That you created, because it's allow list all my buckets for all of your buckets, right? That's what resource is meaning here. So you'll be able to filter a list of all of them, not just some of them. And the third one,
it's allowing to list and get, I guess, objects and buckets on that resource, confidential data, and everything under confidential data.
But
in that bucket, I mean, confidential data is the bucket.
Yeah, but must have
It is allowing
on.
It is allowing to list
I didn't
and
see
get
the condition.
that. It is allowing to list and get that particular bucket only if that particular condition is met, that multi-factor authentication is present.
Yeah.
Only in that case, it will list and get this particular bucket's content.
That's correct. And here it's allowing list and get of what? It's list to what?
Objects.
Objects inside that bucket.
Not only objects, right?
And buckets. Everything that will start with that action.
Let me show you one thing. On the Ec2 service, which is, as you saw, I got a token, so my session just expired. I want to show you the number of actions that this policy is allowing. Just by reading it, you think, okay, it's allowing get objects, list, buckets, probably. But when you go to the IAM service,
and you don't need to know all these things in your memories. I mean, it's every day there are new actions that are added, so it's good that you know where to find them and how to list them, but you don't need to know everything.
Yeah, exactly. And it's not possible. Look at this. This is just get plus list, right? So this policy is allowing all of those gets and those list actions on this bucket. That's true. But also for every object you have under this bucket in this case, because it's using /* and what comes after slash in the S3 ARN is the S3 object prefix. So it's allowing a lot of stuff. So as a good practice, avoid using star in your policies. Be very specific if you know the actions that you want to apply to your users, groups, or roles, because you might be allowing something that's a security problem. It might increase your blast radius and things like that. So it's better to have control on what you're allowing. And just, we have like 5 more minutes. Is that right if we just extend 5 minutes more, guys?
It's okay. And that the condition, the condition saying that multi-factor must be activated in the bucket or something like that.
That's true. And
what? Okay.
That's true. That's the condition. So it won't allow this user group or role to do this action on these resources if it's not using MFA, multi-factor authentication. And multi-factor authentication, in fact, it's part of IAM service as well. So as you received from Kyle in the pre-class setup, probably there's a sentence there saying that we should allow, you should set up the multi-factor authentication in your accounts as root. I'm not root of these accounts. I'm in an organization, and we are doing other types of multi-factor authentication. That's why it's not allowed here. But for sure, if you have the user that's root, you'd be allowing this because all of your billing information is there. So if someone gets your password, it can be a problem. And uses your account, which is worse because it could be thousands of dollars per day. So just coming back, there's a policy evaluation. I won't go through it with you right now, but there are several levels of permissions in AWS. So as I said, I'm part of an organization. So Continuo has the root user that creates accounts, that has permissions, admin permissions in all of the accounts. And I'm just here under as an account that participates in this organization. So as you can see here, everything in this policy evaluation starts as a deny. So AWS denies access by default. And besides that, if there is an explicit deny on a resource and an allow, the deny has prevalence, right? So keep that in mind. Deny overrides allows for the same resources, given the conditions. You need to calculate this, right? Then the next step is organizations service control policies. So this gives the organization the ability to manage what the teams can do with AWS accounts. So for example, an organization can say, you won't be allowed to create any resource outside the Sydney region. Because, well, like banks like NAB, Commonwealth, they don't want their data in US, for example, or Europe. So in an organizational level, they can deny it. So remembering that rule, an explicit deny always denies. So if they deny it once, you cannot do anything about that anymore. So after evaluating organizational policies, it comes to resource-based policies, as I mentioned, policies attached to resources like S3 bucket, for example. Then IAM permission boundaries. It's just one more layer to limit what a permission can do. Even though it can do it in the user level, for example, you can limit just before that. Then you find the session policies. This is about assumed sessions like mine here that I'm using for my CLI. And the last step is the identity based policy, which is the policy you attach to user groups and not roles in this case, because roles will be under the session assumed policies usually. So this is the flow, this is the logic. So if you try to do some action and you get the famous access denied, keep this flow in mind, because it might not be your mistake. It might be blocked in a different level.
So I have one question.
Yeah.
What's the first level of deny? Is it the policy, it says evaluated applicable policies. What is that applicable policies means?
Evaluates all applicable policies. Here, basically, it's going through all of the policies that you can see here, 1, 2, 3, 4, 5, 6. And if there's an explicit deny, it's denying. So basically, it doesn't wait to find an explicit deny here in the 4th column, for example. It does it beforehand. It's the first thing it does. It looks in all policies applicable. So applicable means it will look just in the organization you are. It will look just in the resource you're trying to access. It will look just in the user you're using. And after gathering all of these policies, it will look for an explicit deny. If it finds it, it's denied.
Okay.
And you can have multiple policies attached to your user, to your role, to your group. And if one policy is allowing and the other one is denying, it will also consider the deny as the strongest one. So that's what that is.
Yeah, exactly. So yeah, I think I'll skip this part here. It's about assuming roles. No, I think it's important. So the last bit, guys. So when you create, let's jump into the console to be more practical in this. So when you create a role, the first thing you need to specify here is who can assume this role. Because you remember the role is an identity who is assumable by something. So this is the first step. And here you can see EC2 service, Lambda, a bunch of other services, but you have other options just above it. So for example, if you give me your AWS account number, I could type it in here. And this would be a role that allows your account user, for example, to assume it. For doing what? That's the next step, which is attaching the permission. So let's say S3 read-only access. These policies come with AWS. Usually they use star. So we want, you don't want to use them in the production environment. So I'm allowing you to assume this role to read my S3 buckets. I just give it a name. And it will try to validate the AWS account with non-existing. But that's all for creating a role. When I click this button and this AWS account number is correct, it's valid. So almost all of the, all changes that you do in IAM, they tend or they try to be real time. So if I revoke, if I revoke some access from an user, it will be applied real time. But if the user has an active session with those credentials, maybe you want to revoke those sessions as well, just to be sure you're killing that session with for that user. And the reason for that is that because it may take some seconds for this change to be applied. It tends to be real time, but it's a best effort thing. So usually when you change user permissions, mainly you need to revoke the sessions for those users or roles as well. But besides that, all changes here are real time. So if I come here to this policy, this role, sorry, it has policies. you can list it here. You can see it in a nice way that, in my opinion, doesn't help much. Or you can just read the JSON definition. And here you can add inline policies, both in JSON or using this visual editor for helping you. Or you can just attach more policies. There's no number of policies that I know that you can apply to a role, for example. And this tab here, it's all the trust relationships you defined. So everybody that can assume this role is listed here. You can have more than one. So I can say this, but I can say your AWS account can also assume this role, right? Any question, guys? I think I'm a bit over time.
And you guys did already pretty much this with the exercise of previous class. So you guys should have seen some of these already.
I've tried to find some policies, just not all using AWS console, but it's still difficult to find the whole JSON, I think.
For a specific policy?
Yeah, for a specific policy. I've tried to create my own, but I need to find all these keys and.
Okay, you can just use, for example, this create policy button. It will give you this visual editor. It might be useful. For example, I don't know the permission for deleting internet gateways. So I can just search here for EC2 and I type internet. So I have attach, describe, scribe, delete. So I select that. Resources. Here I can say all resources, which means star or specific. Then I need to add the ARN, you remember? So all resources. And after that, you can just click JSON and it will generate that for you. And you can add conditions here. So MFA required, source IP needs to be within this range. So here again, the CIDR blocks that Kiko just explained on the networking, you can restrict a policy even per IP, source IP. And there are other conditions you can add here. Respect count, ARN, and a bunch of others. So I think this might help you to start with, so you don't need to remember the JSON.
Yeah, great.
All right, any other question? No? In the chat, too?
No,
it's okay.
You need to send that survey.
Oh yeah.
Hold on, guys, just a few more.
There's a survey.
That's true. Let me stop sharing here. Quick survey, guys, if you can fill that. 2 questions, like in 15 seconds. Okay, it's there.
Just remember that for next class, we'll ask you what you guys have done over the days, the kind of stand up. We'll see if we can split the group in a few breakout rooms on Zoom, so we can do a faster stand up. And do the exercise as fast as possible, only for the last days.
Yeah. Depending on the exercises for this one, I think 90% are on networking. And there's one on IAM, which is, yeah, it's medium. And for Agile, we don't have exercises. We'll do the stand up next class.
And leave the IAM for maybe, at least if you want to start with them, just wait for a couple of days because we are just adjusting the location of the file. So in the repository. So just if you can just start by the AWS ones, the networking part.
Yeah.
Don't forget to save the survey, Dennis.
It's not auto-saved. I don't know. First time I'm using this.
Oh, you did last class and you didn't save.
Ah, you did it?
You did it.
I did it?
Yeah.
I might take snapshots or something like that.
Yeah, there was the survey last class, right? I saw that.
Yeah, I
But
saw that as
but
well.
I never saw the results of that.
Yeah, Dennis lost it in the process.
I don't know.
Just learning about Zoom.
With the Zoom, guys. So just 5 seconds more. Okay, guys, that's it. Okay, I think I can do something with the result. I don't know if they are saved or not. That's good. Thank you very much, everybody.
Just a particular this thing. There are people who had asked about the class link, on LinkedIn and personal messages. Do we send them the Zoom recording?
Usually we have YouTube live streaming, but we didn't today. So I'm uploading today's class to YouTube. It might be available in 2 days, I think.
Yeah, you can always share the Zoom. You can always share the Zoom link with your friends. It's not a problem. There are a few people watching this Zoom as attendees.
Mm-hmm.
It's not a problem. The YouTube one is more helpful for later to watch later, and will be available tomorrow or in 2 days. We'll also start linking. We'll post the YouTube links on the repository for future reference as well.
Thank you.
All right. So I think that's it, guys. Thank you very much for joining today, and let us know if you need help with the exercise.
Thank you.
Cool. Thank you, Dennis. Thank you, Kyle.
Thank you, guys.
Thanks so much, guys.
See you then. Bye.
Have a good night.